Hey all, today we are on pages 5 and 6 in our notes. We're going to be dividing exponents. Okay, so our notes look like this, properties of exponents division. Okay, so it says Lightning Speedway has a race car on a display platform. The expression below can be shown or could be used to determine the amount of pressure the car is applying to the display platform. Write the expression in expanded form and then simplify to a single base raised to an exponent. So the pressure right now is being expressed as 10 to the fourth over 10 to the second. So first we're going to simplify, or we're going to expand 10 to the fourth. So 10 to the fourth is a base of 10 being multiplied by itself 4 times. Okay. Then we have 10 to the second in the denominator. 10 to the second means 10 times 10, 2 times. Okay. Then it's asking us to simplify to a single exponent base. Okay. So I just look at, I'm like, okay, 10 divided by 10 is 1. Okay. I see another 10 divided by 10, which is 1 as well. Okay. So all I'm left with is 10 times 10. So we can write 10 times 10 as 10 to the second power. Okay. Use this example and any previous knowledge of properties of exponents to make a conjecture about what to do when you have quotients or dividing in exponents. Okay. If we were in class together, we would kind of talk about what our guess is, but we're just going to test this conjecture and come up with it together. We're going to expand these problems and then write it as a single base and then hopefully come up with this pattern. So we have 2 to the 6th over 2 to the 3rd. So we're going to expand 2 to the 6th as 2 being multiplied together 6 total times, okay, in the numerator. And then in the denominator, we have 2 to the 3rd, 2 times 2 times 2. All right, then I can simplify this by dividing 2's together because 2 divided by 2 is 1. Another 2 divided by 2 is 1. Another 2 divided by 2 is 1. So I have 1 times 1 times 1, which really is just nothing with multiplying. It keeps the number the same. But I still have 2 times 2 times 2. So fully simplified, this could be just rewritten as 2 to the 3rd power. All right. Hopefully maybe you have your idea of what the pattern is. We're going to check one more time. We have x to the 7th, which would be x times itself a total of 7 times. 2, 4, 6, 7 in our numerator, and then in our denominator we have x squared. All right. Now while we have x's instead of numbers, whatever this number is, if we divide it by the same thing, that would still be equivalent to a 1. Same thing right here, another 1. So we have 2 1s being multiplied together by a bunch of x's, x, for x to the 5th. Okay. So some pattern that we're noticing is if we have the same bases, we're keeping the bases the same, but we're taking the exponents, the number of times it's being multiplied together, and we're subtracting to find the new value. So the quotient of powers property says if we have bases, the same base, and we're dividing them, we can simply just subtract their exponents. Okay. Apply the quotient of powers property to write each as a single power. Remember to group like bases. And then apply the property when necessary. So we have 6 to the 10th over 6 to the 8th. So I have 10 up in the numerator and I have 8 in the denominator. Okay, I can just subtract 10 minus 8, or I can just ask myself, how many more do I have? I have 2 more in the numerator. So to show that, I have 6 to the power of 2. All right. With this next problem, we have regular numbers as well. So we're going to have to remember to group them. So first, we're going to do 4 divided by 2. 4 divided by 2 is 2. Okay. Then I can do into the 8th over into the 7th. If I ask myself, I have 1 more in the numerator, or I could do the subtraction. 8 minus 7 is 1. So I have 2 into the 1. You obviously don't have to put the 1 if you don't want to, but you can, and I wouldn't count you off. Okay. Final one, we have 3 groups. We have numbers. So we have 7 to the 14th. Again, you could group them in the problem, or you could rewrite it. 7 over 14 is a decimal. We're going to keep them as fractions. So I'm just going to write 1/2. So I simplified 7 over 14 and made that 1/2. Okay. Then I'm going to group the x's together because, again, we like common bases. So we have x to the 12th over x to the 4th. Okay, I can do 12 minus 4. In my brain, I just like to say, okay, I have 8 more on top, so x to the 8th, okay? And then finally, I have y to the 9th over y to the 3rd. I have 6 more on top. 9 minus 3 is 6, so I have y to the 6th. All right. Now we're going to start talking about just a little bit harder problems. So we're going to apply the property of quotient of powers property to simplify this expression. Then we're going to expand it and see if we can come up with what to do when we have more on the bottom. Okay, so we have 8 to the 3rd over 8 to the 5th. Now, we have common bases, so technically we can just subtract 3 minus 5, and this is technically 8 to the negative 2. Okay, same thing with this one. We have y to the 5th divided by y to the 8th. They're same bases, so we can subtract their exponents, and 5 minus 8 is negative 3. Okay. Now, the way we can also look at it is looking at it in expanded form. So we're also going to expand it. We have 8 to the 3rd, which would be 8 times 8 times 8. Okay? And in the denominator, we have 8 to the 5th, which would be 8 5 times. Okay? If we just think about simplifying, we have 8 divided by 8, a numerator and denominator, which would be equivalent to 1. We have another 1, and we have another 1. Okay? I have nothing in the numerator. I just have 1 and 1 and 1. Okay? But I do have 8 times 8 in the denominator, so I'm going to write that as 8 to the 2nd. All right, now we're going to expand this second problem. Y to the 5th, which would be y 5 times. Okay. And then y to the 8th, which would be 8 times. Oh, okay. Then I'm just going to simplify. Y divided by y, whatever that number is, when I divide by itself, it'd be equivalent to 1. Another 1, another 1, another 1, another 1. Okay. So in my numerator, I don't have anything besides 1s. Okay. And then in my denominator, I have y times y times y, which would be equivalent to y to the 3rd power. Okay. All right, now it says, based on the examples above, complete the equivalence statements for C and D, then complete the negative exponent property. Okay, so in C, we subtracted and we got 8 to the negative 2nd. Then we expanded it and we just noticed that it was also equivalent to 1 over 8 to the positive 2nd. Okay. In D, we subtracted and we got y to the negative 3rd. Okay. And then we expanded it and we noticed that it's also equivalent to 1 over y to the 3rd. Okay. So negative exponents aren't really the best to look at, and we don't really love them. So we always like the positive exponent. So if we ever see a negative exponent, what we're going to do is we're going to rewrite it in the denominator and make it a positive exponent. Okay. So if it's negative, we are going to put it in the denominator and make it positive. Okay, so we are just going to simplify some problems and then talk about various ways to do this. So we have 6 to the negative 7. Right now it's negative. Okay, so when I rewrite this, I'm going to put it in the denominator. And when I do that, I can put it as a positive exponent. Okay, now I have nothing on top, so I'm just going to put it as a 1. So this is simplified to 1 over 6 to the 7th. All right. Now, this problem, we could do it 2 different ways. We could first make everything positive, or we could just apply the property, okay? I'll show you guys both ways, and you can kind of just play around and figure out which way you would like to do it, okay? So first, let's just apply the property, because this is kind of how I do it. So I noticed that we're multiplying, okay? If we're multiplying, I know that I can add these exponents together, okay? Negative 5 plus 9 is 4. So this is just simplified as y to the 4th. Okay. Now, another way that we could do this is to make this a positive exponent first. Okay, so this is y to the negative 5th. So what I could do is I could move it to the denominator, and when I do that, it becomes a positive. Okay, then I have times y to the 9th. So I can actually just kind of put that on top. Okay. Then I notice, okay, there's 4 more in the numerator compared to the denominator, so that could still simplify to y to the 4th. All right. Now this next problem, we have y to the negative 5th over x to the 7th. Again, I'm going to show you guys 2 different ways, and then you can kind of pick which way your brain kind of works. So I notice that we're dividing exponents. Okay, so that means I can subtract them. Negative 5 minus 7, which is x to the negative 12th. Okay, I don't like negative exponents, so what I'm going to do is I'm going to put it into the denominator, and when I do that, I can make it a positive exponent. Okay. Then I don't have anything in the numerator, so I'm going to put it a 1 right there. Okay, so this is the right answer, and that was just using the property and then making it positive if needed. Okay, another way of doing this, okay, would be to move the negative exponent like we did before and then apply a property. So if I don't want this negative exponent right here, I'm going to put it in the denominator. Okay, when I do that, I can make it positive. So what I have right now is I have x to the 7th, because it's right there, and then I move the x to the 5th in the denominator. Okay, now they're both in the denominator, and this is just multiplying, so I can just basically add those exponents together, which is what we have as our answer. Okay, x to the 12th in the denominator. Again, there's nothing technically in the numerator, so we can put a 1 right there. Okay, again, this way works. If you like to just make everything negative and kind of see what you have together, do you need to add or subtract? All right, the final one right here is 1 over x to the negative 10th. Okay, now these aren't common bases, so we really just need to make this a positive exponent. So right now it's a negative exponent in the denominator. So to make it a positive exponent, we just need to move it up to the numerator. So when I move it up to the numerator, I have x to the 10th. Okay, again, these are equivalent, and we're used to seeing positive exponents. Okay, for the expressions below, we're going to apply the quotient of powers property and then simplify. So we have 3 to the 4th over 3 to the 4th. We have the same base, so we can technically subtract our exponents. 4 minus 4 is 0. So technically this is 3 to the 0. Okay. Then what we can do is we're also going to need to expand it and see if we can come up with a new equivalent answer. So 3 to the 4th is 3 times 3 times 3 times 3. 3 to the 4th is 3 times 3 times 3 times 3. Then we can simplify. We have 3 over 3, which is 1. Another one, another one, another one. Okay, so we crossed out everything, but we have 1 times 1 times 1 times 1. This is actually equivalent to 1. So even though everything crossed out, this is still a multiplying problem, so we have 1s all being multiplied together. So anything to the 0 power is actually equivalent to 1. Okay. Now, there are so many different ways we could do these problems. I'm going to kind of go with the way that I preferably like. If you have a different way that you would want to try and see if you get the right answer, go for it. Okay, so we have b to the negative 7th, times 2b to the 7th. Okay, and my gut instinct is to move the negative exponents first. So I'm going to move this down to the denominator. Okay, and when I do that, I can make it a positive. Okay. Now I need to group like terms. So I see a number, which is just 2, okay? And then I have b to the 7th over b to the 7th. So these are the same exact things. So this is technically the same thing divided by the same thing, which would be equivalent to 1, okay? Again, also this is equivalent to b to the 0, which is equivalent to 1, okay? Okay, for this next one, we have 10x to the negative 3rd over 2x to the negative 6th. So first, I'm just going to simplify 10 over 2. 10 over 2 is equivalent to 5. Okay. Now, you can either apply the rule that you know, or you can make them positive. Okay. I'm going to make them positive. So x to the negative 3rd, I'm going to move down. Okay. And then x to the negative 6th, I'm going to have to move that one up to make it positive. Okay, so I moved them and made them positive. So I have x to the 6th over x to the 3rd. I notice that there's 3 more on top than on bottom. So simplified, I have 5 from the whole numbers, and I have x to the third with my exponents. All right. Next one, I see whole numbers, so I'm going to divide the whole numbers. 18 over 9, which is equivalent to 2. Okay. Then I have my x's, so I have x to the negative 2 over x to the third. Again, I prefer, me personally, to move, so I'm going to move this down, and when I do that, I make it a positive. Okay. Then I can just combine those together because they're right next to each other. I have 3 right here and 2 right here for a total of 5. Okay, but notice that they are in the denominator. So I'm going to rewrite this a little bit. My 2 is in the numerator because 9 goes into 18 2 whole times. So I'm going to make kind of a fraction. And I have x to the 5th, but that's in the denominator. Okay. Then we have our y's right here. Okay. I don't really need to rewrite it or anything or move it. I have 3 on top and I have 1 on the bottom, so I have 2 more on the top. So when I rewrite that, I just need to make sure I have 2 more on the top. Okay? And then finally, I have z to the 0. Well, z to the 0 is just equivalent to a 1, so we really don't even need to write it. So this could be simplified as 2 y to the second over x to the 5th. All right. For this last problem, I am going to first get rid of these parentheses. So I have x to the 5th, and that's occurring negative 3 times. The first thing I'm going to do is I'm going to demultiply or kind of distribute that. Okay, so 5 times negative 3 is negative 15. Okay, then I'm going to move any negative exponent. So the negative 15, I'm going to move down to a positive 15. And then x to the negative 16, I'm going to move up to make it a positive 16. Okay. Then finally, I have 16 on top and 15 on bottom. 16 minus 15 is 1, or I have 1 more on top. So I could just write x or x to the 1. Okay. Mr. Williams wrote the following expression on the board. Xander thinks the expression can be simplified to 1 because of the zero power property. Do you agree or disagree? Explain your reasoning. Okay, so the way I would do this problem is I would again move any negative exponents just to see. So this is positive, so I'm going to keep him there. I'm going to move this negative exponent up, and when I do that, I can make it a positive exponent. Okay? Now I have x to the 8th and x to the 8th, which would be equivalent to x to the 16th. So I disagree. And that's because I move with negative exponents. You could also apply the subtraction property, but if I subtract the negative number, that's equivalent to a positive 16. All right, Arlena is decorating the top of her graduation cap. The top of the cap is shaped like a rectangle, okay, with the area being 16x to the third, y to the 7th. Okay? If the length of the cap is 4x, y to the 8th, write an expression to represent the width of the cap. Okay, so we know the length, we know the area, we need to find the width. So it looks like we probably need to divide these two numbers. Okay, so we have 16 divided by 4, which is 4. Okay. We have x to the third over x. We have 2 more on top than on bottom. Okay. And then finally, we have y to the 7th over y to the 8th. We have actually 1 more on bottom than on top. Okay. So this looks like this is the length of the cap. All right, 3 students simplified the expression below. Circle the name of the student who wrote an equivalent expression. So you guys are going to try this one, and then we'll check together. All right, this one is kind of gnarly, so what I'm going to do is I'm going to kind of group everything together, okay? So I'm going to grab my highlighter, and I'm going to do the numbers first. So I see 2 and 3 and 2. So I see 12 over 3, times 2. Okay, 12 over 3 is equivalent to 4, and 4 times 2 is 8. Okay, when I notice, I see an 8 in the numerator, 8 and 8 in the numerator. So 8 has in all of them, so cool, we did that. All right, now I'm going to do the r's. Okay, I see r to the ninth, r to the negative 2, and r to the 4. So r to the ninth, r to the negative 2, and r to the 4. Okay. Again, me personally, I'm going to move any negative exponents. So I'm going to move this guy up and make it a positive exponent. Okay. Then I just have r to the 2. I have 2, 9, and 4. So that means I can add them all together. So it'd be 11, 15. Okay. So when I check, I have 8 and I have r to the 15th. So this looks right. This does not look right. We have r to the 11th, and this one is also right. Okay, so we have to check our s's to see which one is the final correct one. So we have s to the negative 8 over s, and then s to the negative 3 in the denominator. So I'm going to write that over here. So I have s to the negative 8 over s, and then I have s to the negative 3 over here. Okay. Again, I'm going to move everything I can. So I'm going to move this one down and make it s to the 8. And then I'm going to move this one up and make it s to the 3. Okay. Again, if it's kind of hard to see, just rewrite it. So we have s to the 3 in the numerator. And then we have this little lonely s and s to the 8th. Okay. I'm going to combine these together. S with s to the 8th would be 9 s's being multiplied together. Okay. And then I just look and I'm like, okay, well, there's a difference of 6, and there's 6 more in the denominator. Okay, so one that has 6 more in the denominator would be forest. Okay, all right. So for today, I want you guys to practice this assignment. You have to find 2 that have the same answer. We'll practice tomorrow as well. So I would say do the ones you feel confident with, and then come with any questions tomorrow.